Hello everyone, welcome to Unit Guiding Notes 1-4 Accuracy and Precision from Unit 1 Properties of Matter. In these notes we will look at the guiding question, how are precision and accuracy different from each other and why are they both useful? So what do you think the difference is between accuracy and precision is your due now. Complete that in your notes. So for notes, we are going to go over those now. So accuracy and precision are words that are easily confused for one another, but in chemistry they have specific and different meanings. Let's consider the following example. Imagine that you own a company that makes a metal alloy. Alloys, remember, are homogeneous mixtures of metals. You know that the correct density for your alloy is 6 grams per milliliter. So we would say that the accepted value is 6 grams per milliliter. And we have the data here. Accuracy describes how close your data is to the accepted value or a desired target. Whereas, as you can see, both employee B and C were able to produce, so B and C were able to produce the same average density. So we see the mean or average, those mean the same thing, is 6 grams per milliliter. Employee A, however, did not have the correct average. Both B and C are considered accurate based off of their average. However, employee A is inaccurate. Precision, on the other hand, refers to the degree of certainty that you know a value, that is based off of a measurement, or how close your values are together. So we'll look at the first one first. All of this data was calculated with the same number of decimal places. They all have 2. So they have the same degree of precision in all of their measurements. Okay? So a more precise measurement, individual measurement, has more decimal places or significant figures, which is covered in Notes 1-8. If you were to send the alloys, however, from employee B out to customers, you would probably get a lot of complaints. Why is that? Well, if we look back at theirs, you see that employee B has their densities all over. They have some at 8.5 and some at 4. Yes, their average is accurate, but their procedure and their method is very imprecise. So we would compare the data from C and B, and you see that B is very inconsistent. As we saw, 8.5 to 4 was their range, while employee C was able to produce their alloys within a very small range. They are all very close to each other. So when values are close to each other, the data is considered precise. This is separate from accuracy. So employee C has data that is precise or close together and accurate. Its average is very close or the same as the accepted value. Employee A is precise because all of its measurements were very close together, but it is not accurate because the average that they got was very different than the accepted value for the density. Employee B was accurate because of the average being the same, but it is not precise because the numbers were nowhere near each other. Ideally, you want to be like employee C, where your data is both accurate and precise, so numbers are close together and they are close to the average or accepted value. But these are separate concepts, and you can have one without the other. We can describe accuracy and precision quantitatively as well, where accuracy is percent error, and you want to write this equation down in your notes. This is the absolute value. So percent error is always going to be a positive number here because this is an absolute value. These are not multiplying numbers here. They are tied to these 2 asterisks below, where the accepted value is sometimes called the true or real value. And I want to add some notes in here. This is often one you will calculate. Where the experimental value is one that you measure. Sometimes it's based off of calculations from measurements, but it's one that you measure or calculate from measurements. Okay, so it's the difference between accepted and experimental value, absolute value of that, and then you divide by the accepted value and multiply by 100 to get the percent part. Another way to describe accuracy is to report the percent yield of an experiment. Note percent yield values can be over or under 100%, where your experimental value that you got in a lab or whatever is divided by the accepted or the one that you should have gotten, and you multiply by 100 to get a percent. So this is like your grade, where this would be like your points earned. And you would divide it by the total points. And you could get over 100%, which would be extra credit. If it's in an experiment, it's not extra credit. You did something wrong. But for your grade, it would be extra credit. Or if it was under, you lost some points. Precision can be measured using percent difference for your values. This we will probably only do in a lab setting. You would calculate the mean or average, and then calculate the average difference from the mean. So you would find the difference for each value from your average, and then average the differences, and that would be your average difference. And then you take your average difference divided by your average overall times 100 to get that. There is an example in the We Do section for this. In this class, we typically determine precision by finding the percent uncertainty for your measurements, which tells us that this is in the lab. And this will be discussed soon. Okay, so for the I Do, what is the percent yield? So that's what we're finding of an experiment that you should be able to, if you calculated that you should be able to form 1.92 grams of sodium chloride, but when you weighed the sample, it had 1.96. So we look at the percent yield equation, and that is the experimental over the accepted times 100. Okay, percent error would be if you subtracted the 2 and then divided by accepted. Okay, so error and yield are different equations. We were asked for yield, so we're going to pretend it's like our grade from the experiment. Not really, because it's over 100%, but we'll pretend. Where we should be able to form, this would be our accepted value. And then from the experiment, we got 1.96. So on top we would have 1.96 grams divided by 1.92 grams times 100. And doing the math for this, you should get about 102%. For the We Do's, remember that you scan the QR code, watch the video there, and work through it alongside the video. You should try to do these first and then check your work. And once you have done that, pay attention to this one, because this is the percent difference one. Okay, that we went over on this slide. So at the very bottom section of your notes where it says precision is is referencing to this practice problem. When you've completed the we do's, complete the you do. Number 10 is like the second we do. And then after you've finished everything, answer the guiding question at the bottom of your notes. If you were absent, you can upload them to Schoology or save them until you return to class. Thank you.